Hello, students. When we talked about soil solid composition and soil structure, we learned that the soil is porous and there are pores between soil particles and soil aggregates. As well as inside the aggregates, soil porosity is closely related to soil fertility and is an important material property of soil. So, is the size, quantity, and composition of pores the same for soils with different textures? Obviously different. How is the number of pores calculated? How to adjust the porosity of soil? Today, we will learn the measurement and adjustment of soil porosity. First, soil porosity refers to the percentage of pore volume per unit volume of soil in the natural state to the total volume of soil. In practice, the soil porosity is not directly measured, but calculated according to the bulk density and density of the soil. We learned the measurement of soil bulk density earlier. What is the density of soil? It means that the weight of dried soil per unit volume of soil particles excluding intergranular pores is in grams per cubic centimeter. In general, the soil density is usually expressed as 2.65 grams per cubic centimeter, which can be measured separately if there is special need. The difference between soil bulk density and soil density is that bulk density contains pore density, but does not contain pore. We can calculate the porosity of soil according to the known soil bulk density. Soil bulk density is negatively correlated with soil porosity. The larger the bulk density, the smaller the porosity. The smaller the bulk density, the greater the porosity. Too large or too small porosity is not conducive to plant growth. Excessive ventilation, strong water permeability, and easy air leakage and entropy loss. If it is too small, poor ventilation and water permeability will hinder the growth of root system. In production practice, the total porosity of the cultivated layer soil suitable for plant growth and development is between 50% and 56%. It's better if the porosity is above 10%, and it can reach 15% to 20%. The ratio of capillary porosity to non-capillary porosity should be 2 to 1. Invalid porosity should be as low as possible. The vertical distribution of pores in the same soil should be vertical at the top and solid at the bottom. Loose tillage soil is conducive to aeration and water permeability and seed germination. Soil breaking and seedling emergency are the upper deficiency. A little compaction of the lower soil is beneficial to water retention and stabilization of the root system. The amplitude of soil porosity is generally between 30% and 60%. So in production, how do we adjust the soil porosity to achieve the ideal state suitable for plant growth and development and achieve what we want? First, prevent soil compaction. Field operations should be carried out in the suitable farming period, implementing agricultural machinery and tools, combined operation to reduce the number of field operations. Try to reduce tillage and no-tillage to avoid soil compaction. Secondly, rational crop rotation and increased application of organic fertilizer are needed. Measures such as grain fertilizer rotation, water dry rotation, and organic fertilizer application were taken to improve soil porosity. Then, pay attention to rational farming combined with deep plowing and application of organic fertilizer combined with cultivation, suppression, and other measures to improve the pole condition of overtight and overloose soil. Finally, when necessary, engineering measures should be taken to improve the interlayer barrier soil such as iron plate, mortar clay, and sand leakage so as to eliminate the barrier layer and create a good root growth environment. I believe you all have a deeper understanding of these four contents. That's the end of the class. Thank you for watching.